I want to welcome y'all. I'm Susan Crumrine. I'm the Vice President of the Automation and Data Systems Division here at Southwest Research Institute. That's the division that is hosting the ROS-Industrial activity. Anyway, we're glad to have you here today as we kick off the ROS-Industrial Consortium. As you may or may not know, Southwest Research is a fairly unique place. Our mission is to benefit government, industry, and the public through innovative science and technology, and that's very well aligned with what ROS-Industrial Consortium is trying to do. So, you know, we're excited about this opportunity to bring together this group of people and make some neat things happen in industrial robotics. The Institute has experience managing over 74 cooperative research and development projects, which have included over 460 commercial companies, government agencies, through multiple technical activities. So we're not brand new to consortiums. We've done this before at the Institute, and hopefully this particular consortium will be extremely successful also. As an independent nonprofit organization, we're really very well suited to try to bring together people from across different domains to do pre-competitive research and development, which is what we plan to do in ROS-Industrial and through the other consortiums that we host here at Southwest Research. We're excited about this open house today. We're excited to have all of y'all here. As many of you know, this is the culmination of months of work of our technical staff here, but it's also a new beginning of a collaboration that has the potential to significantly impact how industrial robotics are done in the future. That's the hope that we have here today.
Alrighty, so I'm going to give you just a brief overview of Southwest Research, kind of at a glance. Susan already kind of somewhat introduced us, but we were founded in 1947 by an oilman and philanthropist, Tom Slick, and his mission was of benefiting government, industry, and the public through innovative science and technology. And we've been in business for over 65 years, and today we have now over 3,000 employees, and we have exceeded in 2012 $584 million. 60% of that is through government contracts by dollar amount this year, and about 40% was through industry. And we are primarily located in this beautiful 1,200-acre campus here in San Antonio, and you'll get an opportunity to see some of those facilities here later today. And we currently have 2.2 million square feet of laboratories and office space. And we have over 1,000 patents issued to members of our staff and have received currently 36 R&D 100 awards. So just some of the operational characteristics. We are a nonprofit 501c3 type organization. We receive most or solely all of our revenue through contracts. In 2012, we did over 4,000 individual contracts we worked on, and about a little less than 3,000 of those were actual industry contracts, and just a little over 1,000 were government. So while the dollars are more government, the number of contracts we actually execute are more within industry. We are applied R&D, RDT&E type organization. So those are the services we get into. While we do some basic research and we do have some limited production, primarily we stay in the applied area. We do primarily physical sciences and engineering, and we have a very broad technology base and a client base, which allows us, as the ebb and flow of different economic sectors go, we're able to maintain that level of business just because of the diverse background that we have. We are very capital intensive type operation. We invest in the facilities and lab equipment in an effort to be able to do work for our clients. You know, in this day and age, unfortunately, everybody can't have the type of R&D facilities that they'd like to have to do some of this far-reaching work. So we really invest heavily in those areas to stay ahead of the game and allow a space for our clients to be able to utilize some of the technologies and the laboratories and the equipment that they couldn't otherwise afford. We do a lot of internal research and development. We feel it's very key to reinvest and try to stay ahead of the client's needs and to actually go through and develop where the market is going to tend to go. In this last year, we had $7.4 million of work in the internal research and development program, and that covered over 84 different and unique projects. So this is our organizational chart, and you can see that we're governed by a board of directors. We have 11 technical divisions, and there are several that go through all of the different facets, you know, the aerospace, applied physics, applied power, automation and data systems, which is the group and division that we're in. We have chemistry, engines, fuels and lubricant, mechanical, signal exportation, and space science and geoscience and engineering at the top. And so within the automation and data systems division, there are many different departments. And the department that's hosting this particular effort is the Manufacturing Systems Department. And they primarily deal with the automation and robotics and advanced technologies that you're going to have to participate in and hear about a whole bunch later. So the robotics and engineering section, we do have a lot of diverse background. We have capabilities that go from prototype and research all the way through implementation into the field. And these are just a couple slides of the different programs that we have worked on. And it's really, we deal a lot in advanced robotics, vision technologies, sensing technologies, multi-level programming and programming software application development. And these are just to highlight some of the advanced robotic technologies that we have recently worked on and deployed. The very first one is, the acronym is ACRES, and that's for Automated Coding and Removal System, and that is in Hill Air Force Base. And what that is a system that uses starch media to blast the paint off airframe components. In this particular system, 30 different components are actually processed through this booth. It's utilizing an off-the-shelf robot on a custom gantry. And we developed the software and the programming applications to be able to do this effectively. And its big brother is RACS. That's for Raptor Automated Coating Stripping System. And that's the latest one. We just installed that in September 2011. And that one is for full aircraft depaint. And that's specifically for the F-22. You're going to see a little video of it to give you some perspective of what it is. But it's one of the largest robots in the world, if not the largest. And it's a 9-axis custom configured robot. This particular slide down here demonstrates a prototype cell that we did for a company to handle, inspect, and package glass fiber. And this cell we went through to optimize the process and enhance the production, and then this was sent to a second integrator to actually implement into the field. This far one is actually one of our internal research and development programs. It was called Mr. Rome, and primarily it was used to demonstrate mobile manipulation using an independent metrology system to be able to not only locate where the components are within its workspace, but also to be able to identify where the gripper is and reposition based on actual location with the end effector relative to the part. And to give you a little bit better accuracy and be able to do that. That's an actual off-airframe component, and Paul Voss would be able to tell you all kinds of cool stuff about it if you're interested. But primarily what this was able to do was, no matter where you positioned the part or where you started the robot, once you calibrated with an external fiduciary component, it could go and find, using IPGS from Nikon, where it was and how to process. And it actually moved through the different patterns here in multiple different passes, and we were able to establish a very relatively accurate, complete path every single time. So now we're going to give you a little bit of an example of the large-scale robot. This is RAX. It's a 9-axis. It's a custom end effector. And this is just to give you some scale of how large it is. And this end effector has a camera on it. It has custom, yeah. Well, it's got a lot of safeties, and it's got nozzles specific to this particular application. And we wrote, actually, Jeremy was primarily a writer of the software that actually operates this particular robot. And it's able to be utilized by a person, guide through a path, taught effectively with an operator interface. And like I said, that was implemented just here recently in 2011. Now the person you can contact later regarding this is Clay Flannigan. Here's what he looks like in case y'all haven't had an opportunity to meet him. And if you have any questions or need to get in touch with us if Paul's not available, you can always contact Clay or myself. Any questions? All right, well, thank you.